Topic 2, Solids, Liquids, and Gases, Lesson 3, Gas Behavior. It can be found on pages 66 through 75 in your textbook. Alright, as always, we're going to start with the connect it. So when a volleyball sits out in the sun, it becomes warmer and feels more firm. What do you think happens to the particles of air inside the ball as it warms in the sun? So the particles in the ball are going to be moving more quickly. Their energy increases. Apply scientific reasoning. What do you think happens to a volleyball outside on a cold night? So the opposite is going to happen, where the particles inside the ball slow down, so the ball would not feel as pumped up. Pressure and temperature of a gas. Have you ever shaken a snow globe? If so, you've seen how the fake snowflakes fly around. They collide with each other and with the walls of the snow globe. If you shake it more slowly, the snowflakes collide less frequently. The gas particles constantly collide with one another and with the walls that may contain them, similar to the snow globe. Pressure and temperature of a gas. The pressure of a gas is the force of its outward push, in newtons, over an area, in square meters, of the walls of the container. Pressure is measured in units of pascals, or kilopascals. The pressure of a gas can affect the physical properties of an object. Pressure and temperature of a gas. Temperature also affects the pressure of a gas. When you heat a gas, its particles move faster, so the temperature increases. The particles will collide with the walls of their container with greater force and more frequency. A greater force over the same area results in a greater pressure. So now it's time to do our reading check. How does particle motion affect pressure? As the particles move faster, the pressure of the walls of the container increase. All right, pressure in a basketball. When a basketball leaks air, the pressure inside decreases. It loses its bounciness and becomes flat. On each image, write a physical property that changes due to the low gas pressure in the object. So here, in our first one, the mattress becomes less supportive. The lawn ornaments are less rigid and cannot stand upright, and the tire loses its round shape. French scientist Jacques Charles examined the relationship between the temperature and volume of a gas. He measured the volume of a gas at various temperatures in a container that could change volume. Because the volume was able to change, the pressure remained fairly constant. Charles' law. Charles discovered that when the temperature of a gas at constant pressure is increased, its volume increases. He also discovered that when the temperature of a gas at constant pressure is decreased, its volume decreases. This principle is called Charles' law. So, in this image, we have a gas-filled balloon is at room temperature of 20 degrees Celsius. The balloon is submerged in the liquid nitrogen at negative 196 degrees Celsius. The balloon is removed from the liquid nitrogen, and the balloon is again at room temperature. So we're going to draw the arrows showing if temperature increases or decreases with each action, and if volume increases or decreases. So this is what it should look like. For the liquid nitrogen, both temperature and volume decrease. When it's removed, they both increase. But then when it heats back up to room temperature, it also increases. So again, volume and temperature have a correlation that they go in the same direction ultimately. So if the temperature goes down, the volume goes down. If the temperature goes up, the volume goes up. Directly proportional relationships. When a graph of two variables is a straight line passing through the origin, the variables are said to be directly proportional to each other. The graph of Charles' law shows that the volume of a gas is directly proportional to its Kelvin temperature at constant pressure. All right, so let's go ahead and do our reading check. If the temperature of a gas were to decrease, what would happen to the volume of a gas? And because temperature and volume are related, it would also decrease. Now we're going to do the academic vocabulary. In this context, proportional means consistent with. As one variable increases, the other also increases. How else might you use the word proportional? So some examples. A baby's shoe is proportional to a grown-up shoe. It's the same shape but a different size. Pressure and volume. Suppose that you use a bicycle pump to inflate a tire, as shown in Figure 4. By pressing down on the plunger, you force the gas inside the pump through the rubber tube and out of the nozzle into the tire. What happens to the volume of air inside the pump cylinder as you push down on the plunger? And what happens to the pressure? So the volume of air is going to decrease, which means the pressure in turn is going to increase. Boyle's law. When the pressure of a gas at constant temperature is increased, the volume of the gas decreases. When the pressure is decreased, the volume increases. This relationship between the pressure and the volume of a gas is called Boyle's law. Boyle's law describes situations in which the volume of a gas is changed. The pressure changes in the opposite way. All right, so here we have the image of the bicycle pump inflating the tire. And we want to draw two diagrams to show air particles in a bike pump before and after the handle is pushed down. So air in pump before the handle is pushed down is going to look like this, and after like this. So your diagram before the handle is pushed is going to show gas particles loosely packed in a space, and then after is going to show gas particles more tightly packed in a smaller space. Inversely proportional relationships. When volume is low, pressure is high. When pressure is high, volume is low. As the volume of gas increases at constant temperature, the pressure of the gas decreases at a different rate. If you multiply the two variables, pressure and volume, at any point on the curve, you will find that the product does not change. This means that the two variables are inversely proportional to each other. Real-world gas behavior. Behavior pistons are often used in machines in which gas is involved. Pistons move in response to the motion of the particles of gas. For example, pistons in a car engine respond to pressure changes that occur when a mixture of fuel and air ignites. The moving pistons help to turn the crankshaft, which connects to the wheels of the car. So how pistons work, Figure 6. Use what you have learned about gas behavior to understand how temperature, pressure, and volume affect pistons. So the image shows gas particles above a piston in a rigid container. The piston is held fixed. Finish the sentence by circling the correct answer. If the temperature of the gas increases, the pressure on the piston will also increase. So in your textbook, you're just going to circle increase. Temperature and volume. Now the piston is free to move up or down. Heat is applied to the gas in the cylinder. Finish the sentence by circling the correct answer. As temperature increases, the volume of the gas will also increase. Let's try that again. In each cylinder, draw the piston and the gas particles based on the temperature shown. So some heat added here in the first, and then more heat added. They're going to look each respectively like this. So you should draw something similar in your textbook. Pressure and volume. This time, the gas is kept at a fixed temperature. The piston is pushed by an outside force, so the pressure on the gas increases. What happens to the volume of the gas as the pressure increases? And the volume of the gas is going to decrease. Under the cylinders, rank the pressure from lowest to highest, with 1 being lowest and 3 being highest. Rank the volume from lowest to highest as well. So that should look like this. The first one is going to be with the most pressure, then the second, and then the third, and the volume is going to be backwards. or reverse of that. And that brings us to our lesson 3 check. So what relationship does Charles' law explain? And that describes the relationship between temperature and volume. As one increases, the other also increases. 2. If the gas pressure in a ball is low, how will it affect the physical properties of the ball? And the ball is going to appear deformed and deflated. It's not going to bounce like it does when it is inflated well. 3. When the temperature of a gas increases and volume is fixed, what happens to the gas pressure? Why? When temperature increases at constant volume, pressure increases. The particles become more energetic when temperature increases, so they exert more force on the container's walls. 4. How do particles of gas move when there is high temperature and high pressure? They move quickly and bounce off the walls of a container with a lot of force. 5. Environmental scientists collect air samples so they can test the quality of the air. They start with rigid metal containers that are completely empty. The air has been pumped out of them. What happens to the pressure inside the container and the volume of the container as air enters it? The pressure inside the container increases as gas comes in. The volume of the container stays the same because it is made of rigid metal.